Hello, Year 8, it's Mr. Sun again, and another lesson where we're having a look at the environmental impact of design and some issues to do with environmentalism and the use of different types of materials. Now, in the last few lessons, over the last couple of weeks, you've been looking at energy sources, so you should understand about non-renewables and renewable technology. So things like solar compared to coal, nuclear, gas, oil-powered power stations, things like that. And then you've also had a look at the different types of plastics. So we now know that there's two different types of plastics, or two big families of types of plastics, where you've got those thermoplastics, which can be chopped down and reheated and reused, and thermosetting plastics that can't be reused. Now, we know that the thermoplastics can be reheated, they can be reformed into different things. And in fact, an example of that is stuff such as this. Now, this is something I printed out using my 3D printer, and the 3D printer is a good example of reusing a thermoplastic. In this case, it's PLA, polylactic acid, which is one plastic which strangely is not made from crude oil and is actually a lot more environmentally friendly. Oh yeah, this is my cat, by the way. She's obviously really loves the 3D printing. Thank you for that, Stevie. And polylactic acids is something which is also biodegradable, so it's a far more environmentally friendly plastic. They say something such as this. Now this is a sort of squeezy, low density polyethylene or something along those lines, and you can see, if you remember, there should be just on the bottom here somewhere, actually I can't see it on here, LDPE or whatever it's actually made out of. This particular one is rubbing alcohol. So, oh yeah, she's back again. Loves this. Introducing. Always the case whenever you're trying to do a video, you have to have a cat involved as well. Now, with a 3D printing part of it, this is what it starts out as. I don't know if you can see that. This is a reel of blue filament, and it basically is the PLA, the plastic, and it is heated up. So as a thermoplastic, this plastic can be heated up. Ooh, and this is probably why my cat particularly loves playing with this one. I can see that she's looking at this thinking, what you got, Daddy? Yeah, she's going to be back up. No, you can't have it. The PLA, you can actually put that into the printer. It's heated up, and then it's turned into this. So it's squidged out. This is obviously using a gold filament, and that produces your three-dimensional design. Yes, I'm going to put that down there so you hopefully will go and play with that instead of bugging me while I'm trying to record. But actual products themselves, and this is what I'm going to talk about today, the life cycle analysis, because what products are made out of really has an impact on how easy they are to recycle, but also we have to think of how easy they are to manufacture, what impact they have when they're actually being produced. So an example of this one, a very good example of this one, is a mobile phone. Now, if we think about the mobile phone, so if I have my mobile phone, you know, we've got a mobile phone like this. Now, it's in its case, but it's a very, very complex electrical device. It is made up of many different types of materials. I mean, obviously, you've got glass on the front here, but then you've got different types of plastic that form the actual casing. And then you've got a greater degree as well, the contents inside it, the printed circuit board. So you've got all those individual little bits of electronics that go into the actual phone itself. Now, okay, yes, the glass can be recycled. The plastic of the case could be recycled. Some of the other components, like the metals inside, which are quite exotic, they can also be recycled. But, yes, baby, it's also at the same time how you get those individual parts to be separated. Now, when you did on the last lesson, you were looking at stuff in your own home, one of the questions I asked you is, if you've got items that are made up of different materials that are mixed together, that makes it very difficult to recycle. Something like this bottle, or indeed any kind of bottle, I mean, this is just LDPE, recyclable. It's got a polypropylene cap. If I took the cap off, put these into my recycling bin, that could easily be recycled as a thermoplastic. Two different materials, both plastic, both of them recyclable. This that I printed out, PLA, can just go in as it is. It's one material. My mobile phone, though, that's a lot harder to recycle because it's made up of many, many different parts. And in fact, when we're looking at a life cycle assessment, that's where we think about a product and all of its impact on the environment. Because remember, this has to be manufactured. It all has to be manufactured and put together in order to produce a product. Now, if we think about the mobile phone, you've got to have the very rare coppers, silvers, golds, palladium, many different types of rare earth metals, silicons as well. You've got the plastics from crude oil, you've got glass from silicon. All of those individual bits have to actually be gathered. And you can see here in this life cycle analysis, you've got the resources up there in the top corner that you have to mine. No, don't upset the camera. Now, they have to be mined, they have to be taken out of the ground, they have to be refined. And in fact, the processing is just on here. So you've got this sort of processing of the individual components. And then, of course, they have to be manufactured. Now, the processing, the mining has an impact on the environment because you've got to dig them out of the ground. That has an obvious impact. The processing of crude oil needs electricity, and therefore where that comes from. We already know about renewable and non-renewable resources. But also maybe, and as you will find out with a t-shirt in the next video, the production of a t-shirt takes 700 gallons. One t-shirt, 700 gallons of water is used in order to create one t-shirt. So throwaway fashion can be very damaging to the environment, because if that water is contaminated in any way with bleaching or any of those other bits and pieces, then that will mean that you will end up damaging the environment. So the factory itself can have a big impact. Its use of technology and energy as well. The manufacturing of the product, how it's put together, and then its distribution. Don't you walk in front of that camera. You're going to walk in front of that camera, aren't you? That's wonderful. I'm going to carry on. Cat Sensei, this is what happens with these things. Distribution, it has to be packaged. Is the packaging using non-recyclable plastic? So if you think of the way you've got a horrible sort of polystyrene, the white stuff that's horrible and squeaky. If that's involved in the packaging, then what will happen is that's got to be recycled. Cardboard, you're seeing far more products being packaged using cardboard instead. My father purchased a new mobile phone, and his mobile phone turned up and there was no plastic in the packaging. Samsung phone, all cardboard, which was great because all of that could just be put in to be recycled. This obviously has an effect on its environmental impact of that mobile phone. The cost of it to be moved through the world so that it may be made South Korea, it's got to be shipped, probably in the ship. A ship will use diesel probably to run, so therefore that is a fossil fuel, a non-renewable resource, and that is producing CO2 and other emissions that go into the environment. And then even when it's on a truck going to the shop, or if you buy it off Amazon and the guy delivers it, he's driving a van that it may be petrol or diesel. This has an impact, so it's using energy. And then finally, you've got its use. Now, mobile phones actually in use very little electricity. So this little bit of the life cycle just here is probably quite small. It uses only a small amount of energy. You're recharging it, and hopefully it's going to be used over a number of years. But this has taken a lot of technology and a lot of resources to create. And then how long do you use it for? 24 months, 36. And then what happens to it? And really, that's the other key thing. When it gets to this point where it's no longer usable, and I mean, I've had this now over 2 years, and lots of people would probably, actually, getting on for 3 years. And a lot of people would think about, getting a new phone. But then this is perfectly fine. What happens to this? Does it end up in a drawer? Do I pass it on to another member of my family? Do I sell it on eBay or Gumtree or Facebook Marketplace to give it a little bit more use, a bit more life? Or does it have the worst possible thing and it ends up in the ground again? I throw it in the bin, which, let's face it, I could put it in my black bin, it would be taken away, and it'd end up in landfill. And this would be there, maybe with many other devices in the ground for thousands of years of times, to future archaeologists to go, oh, that's interesting. Look at these strange and weird things that we found in the ground. This all has an impact on how we should hopefully, this end of life, be recycled. So this is what we call life cycle analysis. Some objects are far more damaging to the environment because of the way in which they're produced. A good example, obviously, is mobile phone. Another one would be a car. A car uses a lot of complicated materials that are put together in factories that use a lot of energy, and they use a lot of resources, and then in use they possibly use a lot of energy as well, especially with their diesel or petrol engines. And then at the end of their life, what happens to them? They're crushed, are bits taken away to make new cars? Very, very hard to figure out. Now, what I'd like you to do today, we've got some videos, and there's a couple of videos. There's two just here, and I've linked them in Show My Homework as well. And they go over, the first one talks about life cycle analysis again. So it's largely talking about what I've spoken about already. The second one, which I think is the most important, is this one. And this gives an example of a fairly simple bit of packaging for some cosmetics, and the difference in life cycle analysis between a plastic version and a glass one. Now, knowing what we know about plastics being bad, in inverted commas, and glass hopefully being really easy to recycle, you'd probably think that the glass one would be better. I want you to watch that and make your own judgments, and you'll see what they say about which one's better. The other one talks about life cycle analysis generally. So I want you to first watch both of those videos after this one, and then I want you to find a product around your own home and do a life cycle analysis of it. You don't have to take a photograph of it. You can just literally write down what the product is in the center and do it in a very similar way to this diagram here. I would think about all of these, and you've got just here 6 individual steps where you've got the resources, the processing of the resources, the manufacture, distribution, the use, and end of life. And what I want you to think about, what materials are used. So think about, and I've also put here, choose a fairly simple item. So it could be something like, I mean, I've got just here, let me just move the microphone slightly out. I have got a computer mouse. Now, that's fairly easy. It is an electrical device. It's got, as far as recycling is concerned, it's got a few different bits and pieces in here and symbols on the back that hopefully will tell you a bit more about it. But it's a fairly straightforward, I would say it was a thermoplastic. It's hard thermoplastic for most of it, but of course it's got electronics inside. So you can think about what materials have been used. Which of these materials do you think are recyclable? So I know that the plastic probably is. What do you think, Stevie? There might be other bits that are inside here. It's got rubber on the wheel that might help me out. Maybe some of the electronics could be reused. It's harder though. Do you think the product is easy to recycle? Explain your thinking. I think this is quite hard. I think this would end up, don't you, Stevie? I think this would end up being quite difficult to recycle. Obviously, Stevie thinks the same. There's no screws on the bottom, which means that it's very difficult to take apart. How do I take it apart? How do I get the plastic out? I could smash it, take it apart, and then I could have this bit of the plastic could be recycled. But are you going to do that? Is that something that you would normally do? And how could the design be improved? Well, with this, simply, it could unscrew. It could come apart so that the actual electronics on the inside could be reused, and they could be sent off to a place where they could be reused, and the plastic at least then could be used for another mouse. If it stops working, you could possibly even have it so that it could be easier to repair, and that's something that we'll come on to a bit later on. And then finally, an extension task. How could recycled materials be used to make the product more environmentally friendly? So is there other materials that could have been used instead of plastic? I want you to think about that one. Maybe get a bit creative and justify your answers. Now, on there, really, you've got 3 or 4 paragraphs that you're going to have to do. You can do it in Word, you can do it in PowerPoint and upload those, or indeed you can do it on plain paper or lined paper and just upload it. Very, very straightforward. Hopefully that's nice and simple. Watch those videos, and I look forward to seeing your submissions. Take care and keep yourself safe.